Chemistry Chapter 7, Gas Laws, where Dalal sums. Page 123, long answer questions. The first sum is very easy. Mark it as read. Second sum, let's understand how to solve that. At 0 degrees Celsius, so the temperature is 273 Kelvin. Remember to convert it to Kelvin in every sum. 760 mm Hg pressure is given. A gas occupies volume of 100 cc, cubic centimeter. Always write the data first. The Kelvin temperature of the gas is increased by 1/5. Increased by 1/5 means now it is 6/5 of 273. If it is decreased by 1/5, then it will be 4/5 of 273. It's like 1 minus 1/5. If you do LCM, it is 4/5. If it is increased by 1/5, then this is 6 upon 5 if you calculate the LCM and solve for it. So now I can directly write this as 6 upon 5 into 273. No need to solve further because 273 will get cancelled ahead in the sum. The pressure is increased 1.5 times. So the new pressure is 3 upon 2 into 760. Calculate the new volume. Since we are solving with P1, T1 and V1, gas equation will be used by the full name, gas equation. Substitute the values, 760 cancelled, 273 cancelled, this goes up, this goes down, and find the value of V2, 80 cc. Now, additional questions. Fourth sum. What temperature would be necessary, so temperature question mark, to double the volume of a gas? So let the volume be 100 liters because they have not mentioned anything. Double it, so 200 liters. Assumed values. If the pressure is increased by 50%. So again, I'm going to decrease by 50%. So I'm going to assume the pressure to be 180 atm, which is the standard temperature and pressure. They have mentioned standard temperature and pressure. Standard temperature is always 273 and standard pressure is always 180 atm. I could have used 760 mm Hg also. It is decreased by 50%. That means the new pressure is half atm and the new temperature is asked. So again, gas equation, substitute all the values and you get the same answer as the initial temperature. The final temperature is again 273 Kelvin, which is 0 degrees Celsius. Don't forget to convert it to degrees Celsius in the end. So this means that if you double the volume and half the pressure, temperature remains the same. Next, fifth sum. This was the fourth sum, now the fifth sum. A gas cylinder has a capacity of 20 liters and it contains 100 atmosphere gas. Pressure is given. How many flasks of 200 cc each? Now this 200 cc is a volume of a flask. Don't imagine it to be V2. No, V2 we have to find. And when the pressure in the flasks is 1 atm and the temperature is constant. Since the temperature is constant, we will use a Boyle's law. P1, V1 is equal to P2, V2. Substitute the values. Get the new volume as 2000 in 2000 cc. So initial volume was 20 liters, new volume is 2000 liters. I'm converting it into cc, multiply by 1000 for that. This is the new volume in the big tank. Now this gas has to be filled in various flasks and each flask's volume is 200 cc. So the number of flasks is the total volume which we just found out by using Boyle's law divided by the volume of one flask, which is coming out to be 10,000 such flasks. Next, AQ number 6. The volume is 850 ml. Pressure is 760 mm of Hg. On increasing the pressure, it was found that the volume of the gas was 75% of initial value. It is not increased or decreased by 75%. It is 75%. So the new volume is 75% of original volume. 75% means 75 upon 100, that is 3 upon 4 of 850. So find the new pressure. Temperature is constant, so once again, Boyle's law. Substitute all the values and you get the new pressure as 1013.33 mm Hg. Now the eighth question. At a given temperature, the pressure of a gas reduces to 75% of its initial value. So initial value is not given, so I'm going to assume volume to be 100 liters and the pressure as 1 atm. Now the pressure reduces to 75%, so that will be 0.75 atm. And the volume increases by 40%, so the new volume will be 140%. If it increases by 25%, the new volume is 125% of original volume. If it decreases by 40%, then the new volume is 60% of original volume. If it increases by 40%, it is 140% of original volume, which is 140 liters. These are assumed values. If the initial temperature was minus 10, what's the new temperature? Don't forget to convert it to Kelvin before substituting. Use the gas equation again, cross multiply, you'll get the answer in Kelvin, but don't leave it like this. Convert it into degrees Celsius. How do we convert Kelvin to degrees Celsius? Subtract 273. Next, UT, unit test, page number 124, question 3, second one. A gas at minus 33 degrees Celsius, converted to Kelvin, initial temperature, is heated to 127 degrees Celsius, final temperature, converted to Kelvin at 273. Calculate the percentage increase in the volume of the gas. Again, volume is not given, so I'm going to use the 100 method. Assume volume to be 100 liters. So we'll find the new volume. This time we'll use Charles' law because pressure is constant. V1 upon T1 is V2 upon T2. Substitute the values and the new volume is 166.6 liters. That's not the actual volume, it's an assumed volume, but that's okay because now I have to find the percentage increase. The percentage increase in anything is the increase or decrease, the change in volume upon the original volume into 100%, which comes out to be 66.67 percentage increase in volume. Next, question 3.4. Calculate the temperature at which gas A at 20 degrees Celsius, converted to Kelvin, having a volume of 500 cc, will occupy a volume of 250 cc. So what's the new temperature? So again, we'll use the Charles' law here. V1 upon T1 is V2 upon T2. Substitute the values, get the answer in Kelvin, and then convert it to degrees Celsius by subtracting 273. Next, question 4.1. The pressure of a gas having volume 1000 cc is to be found out. Originally occupying 1500 cc, and the original pressure is 720 mm of Hg. Very straightforward sum. Temperature is constant. Boyle's law. P1 V1 is P2 V2. Substitute the values, get the answer 1080 cc. And finally, UT question 5.5. The temperature. Find the temperature to which the gas has to be heated to triple its volume. If the gas originally occupied 150 cc, so original volume is 150 cc, so new volume is triple of that, 3 into 150 cc. And the original temperature was 330 Kelvin, find the new temperature. Well, Charles' law says that if the volume is tripled, the temperature will also be tripled, so it's 990 Kelvin, straightforward. And since they gave the temperature in Kelvin, I kept the answer also in Kelvin. Hi students, this is AJ sir. If you found this video useful, press the like button. Also, if you'd like to enroll for my test series or online lectures, email me or message me on Instagram. Check my description for more information.